For topic 3, we're going to go ahead and start talking about multiplying whole numbers. We're going to look at the actual process, and there are a couple of little things to remind you of and just make note of. First of all is calculator usage. I've mentioned this with addition and subtraction. There's a time and a place where a calculator is completely appropriate, but we're still teaching you how to do these steps for addition, subtraction, and now multiplication. You need to understand the basics, okay? So there will be a time where you are assessed on the basic operations where a calculator won't be allowed. And then once we know that you kind of understand the process, the calculator is completely reasonable at that point. When it comes to multiplication, there is the issue of knowing your multiplication tables. Some people just don't have those multiplication tables memorized. So what I will do for multiplication is I will allow a multiplication table even if calculators are not allowed. Okay, so if you haven't memorized your multiplication tables, it is going to slow you down. Okay, you're going to be at a disadvantage not knowing your multiplication tables, but I don't want that to hold you back from being successful in this general idea. Okay, so multiplication table, I'll always allow that. All right, even if a calculator is not allowed, a multiplication table will be. Okay, so there's that. Second, at the very beginning of this chapter, we talked about something called expanded form. Now, we don't see expanded form exactly here, but expanded form is what makes what we're going to do viable. Like it makes it legal. Okay. So if we had something like 579, we would write this as a sum. And the way you do that is you take each digit and basically multiply it by its place value. So 5 is in the hundreds place. We would take 5 times 100. That's 500. So we're going to start by thinking of this so far as 500. You go to the next digit, which is 7. It's in the tens place. So you want to think of that as 7 times 10, which is 70. And then the digit in the ones place just stays in the ones place. So another way to think of 579 is it's 500 plus 70 plus 9. And again, we don't see that necessarily exactly as is, but it does come up. It makes what we're going to do work. Okay. Now, as far as the steps for multiplying whole numbers, sometimes seeing the steps just written out in words doesn't really make sense until you see them applied to the process. So just be patient for now. Let's go through the steps. And then once you see the process happening, hopefully those steps will make more sense. Now, one step that I didn't include, it's kind of just assumed, but maybe you don't know that this is assumed. So let's go ahead and write it out. When you're multiplying whole numbers, the first thing you want to do is write the problem vertically. Okay. So write problem vertically. Okay. And by doing that, it's just going to make the multiplication process a lot easier to work with. Just like with addition and subtraction, we kind of started by writing things vertically. Okay. Now, once you do that, these steps, again, they may not totally make sense until you see them in the process, but let's go ahead and read through them. The next step is to multiply the ones place of the bottom number. So once you write it vertically, whatever that second number is, you take the digit in the ones place and multiply it by each digit in the top number. Okay. You're then going to come back down to that second number and you're going to multiply the digit in the tens place by every digit in the top number. Okay. You do have to do this weird thing with a zero placeholder. Since we're technically multiplying by something in the tens place, we have to keep that zero from the 10 in the problem. So we start by writing that zero in the tens place first, and then we multiply all of the digits in the top number by the digit in the tens place. And I'll show you what this looks like when we actually do the problem. And then if a single product at any point is more than 9, you keep the digit in the ones place, you carry the digit in the tens place. Okay, again, I'll show you all of this. And whatever you carry gets added to the next product. And then finally, you're going to have these partial products. You add your partial products. I'll explain exactly what that means when you see it in the problem. And this process can be expanded to where if the second number has 3 digits or 4 digits or 5 digits, you just kind of keep this process going. You keep expanding it. Okay, so maybe that doesn't quite make sense, yet, no problem. We'll get to the point where it does. So example 4 says find each product. And the first example, really straightforward. We just have 24 times 9. So I'm going to write this vertically. You want to right-hand align everything. So I have 24 times 9. And the second number is just a single digit, so there's nothing really crazy here. So we just want to take the 9 and multiply it by each digit in 24. So starting with the 4, we get 9 times 4. Now remember, make sure you have a multiplication table. It's allowed always. If you don't know 9 times 4, it is going to slow you down. So I would work on trying to memorize some of these multiplication tables. But 9 times 4, 36. Okay. So because that's more than 9, we want to keep the digit in the ones place, which was 6. And then we want to carry the digit that was in the tens place, which was 3. So 36, the 6 is in the ones place, the 3 gets carried. And then we add that 3 to the next product. So 9 times 2 is 18, but we want to add the 3. So 18 plus 3 is 21. Since that's our last product, we write out the full 2-digit number. So we would say the product of 24 and 9 is 216. That would be the same as taking 24 and adding it to itself 9 times. It would also be the same as taking 9 and adding it to itself 24 times. But who wants to do that? Who wants to take 24 and add it to itself 9 times? That would take a long time. Who would want to take 9 and add it to itself 24 times? That would take a really, really long time. This is a shortcut. This is a shorthand way of doing repeated addition. Okay, let's look at part B. So part B is a little different because we do have a 2-digit number for that second number. So we're going to start by writing this vertically. So I get 46 times 32. And we're going to start with the 2 and 32. And here's what's really happening. This is where that idea of expanded form is important. If you think about 32, that could be thought of as 30 plus 2. So what we're doing is we're technically taking 2 times 46, and then later we're going to take 30 times 46. So that idea of expanded form is going to create 2 different products. Those are the partial products that we talked about in the steps. These partial products are what we're going to end up adding. So it's like this idea of expanded form creates these smaller products, and the sum of those products becomes the product of the whole thing. Okay, so let's go ahead and start with this 2. We're going to take 2 and multiply it by each digit in 46. So we're going to start with 6. So 2 times 6 is 12. I want to keep the 2 and I want to carry the 1. Now I take 2 times 4 and I add the 1. So 2 times 4 is 8. 8 plus 1 is 9. I'm done with that 1 that I carried. So if you want to mark it out or erase it, fine. It's done. You've already used it. It doesn't get used again. Okay? So we're done with this partial product here. We can say now that 2 times 46 is 92. So we're done with that partial product. We now need to come and get the second partial product, which is really 30 times 46. But we don't really know how to multiply 30 and 46. But I could take the 3 and 30 and multiply it by 46. That would be reasonable. So what we do, this 0 and 30, that's kind of like 3 times 10. That's the 10 part. We're just going to move it right here, and it just becomes our placeholder. So instead of multiplying by 30, if we put that 0 right there, we can just multiply by 3's, and that's easy for us. So now I'm going to take 3 times 6. 3 times 6 is 18. I'm going to keep the 8. I'm going to carry the 1. I then take 4 times 3, which is 12, and then 12 plus 1 is 13. Since it's my last product, I go ahead and write the full 2-digit number. These are the partial products. So we already knew that 2 times 46 was 92. Now we know that 30 times 46 is 1,380. If we add these two things together, we get the full product. So 2 plus 0 is 2. 9 plus 8 is 17. Keep in mind you are adding at this point. So we keep a 7, carry a 1. 3 plus 1 is 4. And then I just bring down my 1. There's nothing to add to that. So my final product here is 1,472. Okay. So there you have it. That is multiplying by 2-digit numbers. It just becomes this weird process of taking this expanded form idea, finding these partial products, but we do it all at once, which makes it a little quicker and shorter for us. All right, let's look at part C. So part C, we have a 3-digit number times a 2-digit number. It's going to work just like part B did. We just have an extra multiplication for each step. So technically what's happening is we're thinking of 78 as 70 plus 8. We're starting by multiplying 8 times 492. And then we're going to come back and we're going to take 70 and multiply 70 by 492. And this is where we really get the shortcut, is that 70 times 492. So that's what's creating our partial products. You don't have to do that work, though. We're going to do it all in this process that I'm getting ready to write out. So let's start by writing this out vertically. We have 492 times 78. And I'm going to start with the 8. Remember, this is my 8 times 492. This is my first partial product. So 8 times 2 is 16. I'm going to keep a 6. I'm going to carry a 1. 8 times 9 is 72. And then I add the 1 I carried, so that becomes 73. I keep a 3. I carry a 7. And then 8 times 4 is 32, but we have to add 7. So 32 plus 7 is 39. Since that's my last multiplication for this row, I'm going to write out the full 39. Okay? So that's my first partial product. That is 8 times 492. Okay? Now I'm technically multiplying by 70. So this 0 in 70 is going to come right here. And then I can just multiply everything by 7. It's just easier for us. So now I'm going to take 7 times 2. I'm going to mark out these things that I carried because they've already been used. I don't want to use them again. So now I'm going to take 7 times 2, which is 14. I'm going to keep the 4. I'm going to carry a 1. 7 times 9 is 63. And then I have to add the one I carried, which is 64. So I keep a 4. I carry a 6. And then 7 times 8, or not 7 times 8, 7 times 4 rather, excuse me, 7 times 4 is 28. And then I want to add 6, which makes it what, 34. And because it's my last product for this row, I can write out the full 34. Now these are my partial products. The first row is the 8 times 492. The second row is the 70 times 492. If I add these two partial products, I get my final product. So 6 plus 0 is 6. 3 plus 4 is 7. 9 plus 4 is 13, so keep a 3, carry a 1. 4 plus 3 plus the 1 that I carried is 8. And there's nothing to add with a 3 here, so I just drop it down. So I would say my final product is 38,376. And this is a huge time saver because who would want to take 492 and add it to itself 78 times? That would take forever. Who would want to take 78 and add it to itself 492 times? That's ridiculous. It would take forever. This is our shortcut to the whole thing. Okay. So this is how we do multiplication with multiple digits. Okay. So last up, let's look at a 4-digit number times a 3-digit number. Even though that second number is 3 digits, it's the same idea. We're going to have 3 partial products though. Okay. So if you want to think partial products, we have 376. We could think of that as 300 plus 70 plus 6. So the first partial product is going to be 6 times 3. Not 6 times 3. The first partial product is going to be 6 times 2,468. The second partial product is going to be 70 times 2,468. And then eventually we'll get to this point where we have a third partial product, which is 300 times 2,468. But instead of doing 3 problems, let's just do 1 problem. We're going to take these ideas and merge them. Okay, so let's start by writing this out vertically. So we have 2,468. We want to multiply that by 376. So we're going to start working on this first partial product here. 6 times 2,468. So we're going to start with 6 times 8. Well, 6 times 8 is 48. So we keep the 8. We carry the 4. 6 times 6 now, that's 36. Plus 4 makes it 40. So I'm going to get 0, carry another 4. Ooh, my screen just dropped, scared the crap out of me. Now we've got 6 times 4. Well, 6 times 4 is 24, plus the 4 we carried is 28. So I'm going to keep an 8, carry a 2. 6 times 2 is 12, plus the 2 that we carried is 14. Since this is the last digit multiplied, we're going to go ahead and write out the full 14. So we have our first partial product. 2,468 times 6 is 14,808. Okay? Now we're going to technically multiply by 70. So the 0 in 70 is going to come over here as a placeholder, which allows us just to multiply the 2,468 by just 7. Okay, so let's do it. I'm going to go ahead and erase the digits that I carried for the first layer just so we don't get confused and add one back in. They've already been used. They don't get used again. Okay, so 7 times 8 is 56. So I'm going to keep the 6. I'm going to carry the 5. Okay, 7 times 6 is 42. 42 plus 7 is 47. So I'm going to keep a 7, carry a 4. 7 times 4 is 28. 28 plus 4 is 32. So I'm going to keep a 2, carry a 3. Okay. Now 7 times 2 is 14, plus the 3 that we carried is 17. And since that's the last digit, I'm going to go ahead and write out the full 17. Okay. Now we're done with the second partial product. So what we're technically doing now is we're going to be multiplying by 300. So let's think about that. 300, we don't want to multiply by 300 or 30. We want to multiply by just 3 if we can. So we have 2 zeros here. The 2 zeros in that hundreds place they're going to come here as the 0 placeholders. That allows us to just multiply by the 3 instead of the 300. Okay, so let's get to it. So let me erase the things that we carried from the last step. I just don't want to accidentally add one in again. Okay, so I have 3 times 8, which is 24. So I keep the 4, I carry the 2. 3 times 6 is 18, plus 2 is 20. So I keep a 0, carry a 2 again. 3 times 4 is 12, plus 2 is 14. So I keep a 4, carry a 1. And then 3 times 2 is 6, plus 1 makes it 7. So we now have our third partial product, and we want to add these. Okay, so we've got our partial products, all 3 of them. And if we can add those, we get our final product, okay? So 8 plus 0 is 8. 0 plus 6 plus 0 is just 6. 8 plus 7 is 15, plus 4 is 19. So keep a 9, carry a 1. 4 plus 2 plus 0 is 6, plus the 1 that we carried is 7. And then 7 plus 4 is 11, plus 1 is 12. So keep a 2, carry a 1. And then 7 plus 1 is 9. So our final product is 927,968. And who on earth would want to take 2,468 and add it to itself 376 times? It would take forever. Who wants to take 376 and multiply it by itself 2,468 times? Nobody. But this process of multiplication, not so bad. Okay, so just know the heart and soul of what you're doing is you're taking that second number, you're thinking of it in expanded form. Each portion of the expanded form is getting multiplied by the first number. We just have a shorthand way of doing it, okay? So that's what this whole long multiplication process is, just shorthand, okay? So there you have it. That is multiplying whole numbers, okay? So get some good practice in. It's not the hardest thing you're ever going to do, but it does take a little getting used to the process, getting used to the setup, making sure you're kind of getting better at those multiplication tables. Again, I'm not going to require you to have your multiplication tables memorized, but it's going to help you a lot in the long run, okay?